everyone. I'm Dr. C. Kavita from SRM Valiam Engineering College. Now I'm going to explain about a concept, classification of signal. So this comes under the subject signals and system. So now we are going to see about the topic. Before seeing that, we have to understand what is a signal. So signal is nothing but a variable or entity that carries some information. This is a function of one or more independent or dependent variables. So basically, it is nothing but a physical quantity that varies with some independent or dependent variables. So the signal can be either one dimension or two dimensional in nature. So to tell you as a clear definition, we can say a function of one or more variable that convey information on the nature of a physical phenomenon is called a signal. So this signal, when it is one dimensional, is only dependent on one variable, that is time. For an example, speech signal. And one, it is a multidimensional nature. It depends on two or more variable. This can be given by an example of image. So image, we can have two or more variables, that is based on the pixel, based on the intensity changes, the signal changes. So that is what we call it as two multidimensional signal. And many more multidimensional signals are present in real time. So the next is the classification of signal. So the classification of signal, when it is concerned with the signals, we have two type of signal. One is continuous time signal, other one is discrete time signal. So the continuous time signal is a signal which is present all throughout the time, and the discrete time signals are signal that is present only during discrete time periods. So discrete time signal or random signal as the one of the classification. The next one is periodic or non-periodic signal, and third classification is energy or power signal. Fourth one is causal or non-causal signal, and fifth one is even or odd signal. So the deterministic signal is a signal that is easily predictable, and the outcome of the predictable events are can be given as a signal whose name is deterministic signal. So there is no uncertainty, and this can be easily expressed in mathematical terms. So the deterministic signal is given here, and this example is x of t is equal to sine 3t, and we know the outcome of the sine signal, so we can easily predict the deterministic signal. So random signal. So next one is random signal. So random signal is a signal that whose outcome is completely unpredictable. So in an event which has to be explained by a random signal, which is unpredictable, is called a random signal, and this signal cannot be easily mathematically represented, and the signal can be given in terms of some standard probability and random processes that is available with the help of some distribution, and its standard distributions are available to represent the random signals. So these distributions can be given to explain the random signal. So one example is thermal noise that is generated during the transmission of a signal, or random signal. Thermal noise is present in all the electronics devices, or transmission or communication. So these type of signals are random in nature and is called non-deterministic signal. So next is periodic signal. So periodic signal is nothing but a signal that repeat itself with a standard time period, that is fundamental time period, or signal that repeats itself with a fundamental time period is called periodic signal. For example, if we have been given a signal x of t, this x of t is periodic if x of t is equal to x of t plus capital T. So whenever we have a signal that is repeating itself with a time period, that is capital T naught, is called a periodic signal. Here T naught or T is an integer of n. So this signal you are seeing is x of t is repeating itself again and again with the time period capital T. So this signal can be called as periodic signal. So next is non-periodic signal. So the signal that does not repeat itself within a fundamental time period. or it can repeat itself but with not the fundamental time period. So both the conditions should be there. It should repeat itself with the time period, that is fundamental time period. Only one time period is allowed. For example, if we have 5 seconds as a fundamental time period, the signal should repeat itself by 5 seconds. So within some 5 seconds, it will change again and again into the same repetitive pattern. So these type of signals that does not follow these conditions is called non-periodic signal. So this non-periodic signal will have time fundamental time period as infinity. It may not occur also. So the example of non-periodic signal is a exponential signal. So exponential signal can be termed as non-periodic signal. So energy signal. So next signal is energy signal. The signal that has finite energy and zero power is called energy signal. So this energy signal can be represented with the equation given here, that is E value should lie between 0 to infinity and P value should be 0. So the signal energy of a signal is defined by the area under the square of the magnitude of the signal. So the unit of this particular energy signal is depending upon the unit of the signal. Next is power signal. The signal that have infinite signal energy and have finite power is called power signal. So the power signal is given by the power should lie between 0 to infinity and energy should be infinity, and the average power of the signal is given by limit t tends to infinity and 1 by t into integral of minus t by 2 to t by 2 into x of t the whole square into dt. So this is the formula for the power signal. So next one is even or odd signal. Even signal and odd signal are defined by x of t is equal to x of minus t, that is even signal, and x of t is equal to x of minus x of minus t is the odd signal. So if you see any signal is the sum of some unique odd and even signal, using this combination, that is x of t is equal to combination of even signal and odd signal, is called the total signal. So even signal is nothing but x of t is equal to minus x of t, and odd signal is nothing but x of minus t is equal to minus x of t. So any signal x of t can be represented by addition of both even and odd as well as subtraction of both even and odd. So even part of the signal is given by x of t plus x of minus t divided by 2. Similarly, the odd part of the signal is given by x of t minus x of minus t divided by 2. So next classification is causal and non-causal signal. So the causal signal is given by x of n is equal to 0 for n value lesser than 0, and the anti-causal signal is given by x of n is equal to 0 for n value greater than 0. A causal signal does not exist only for negative time period, and anti-causal signal does not exist for positive time period. So this is what we can have. So causal signal will not have negative time period and anti-causal will not have positive time period. So signal that is existing in both the positive and negative is called non-causal signal. So this is what we call it as classification of signal. So based on this classification of signal, we can easily categorize the signal that is required for processing. So one should have a clear knowledge about this classification of signal in order to work with the signals and system and its processing. And so a signal engineer should be very clear about the classification of signal for particular application. Hence we have given a clear understanding about the classification of signal, and this classification of signal may be used for creating many other complex signals. So we have a lot of signals that is carrying lot of data. So this signal and its properties and its application should be very clearly understandable, and one should have a clear knowledge about these signals, and that is why we have gone through this YouTube video. So I hope it is very helpful for you, and thank you one and all.